I'm Dr. Kate Bieberdorf, but you may know me as Kate the Chemist.
Kate is a scientist, author, and science entertainer.
Today, I'm going to break down clips from movies and TV about chemistry. So let's experiment. Dissolving a body, Breaking Bad. It's possible that HF could dissolve a body, but I would not pick that one because HF is a weak acid, and so that means that it doesn't fully dissociate into the hydronium ion, and that's the active species that's actually going to start eating away at the tissue. So if it was me to dissolve a body, even though I shouldn't be saying this, I would probably go with something closer to aqua regia, which is like a royal acid. That last scene makes me cringe. He's standing next to a huge container of HF, so hydrofluoric acid, that is being suspended in the air, and he doesn't have any safety equipment on his face. So like that thing could break and splash in his face and just, he'd be done so. No thank you. When you add acid to something, it is going to start to react immediately. We have a saying in lab that you add acid to water, do what you oughta, because if you add it in the opposite direction, it starts to rip things apart in a really treacherous way. So we usually would take a body.
Help me out, Professor.
No, we wouldn't. We would usually take a substance and then add acid to it.
We're ready to go to work.
Sniffing chemicals, It's Always Sunny in Philadelphia.
I'm stuck to your glue.
What about gasoline? Pour a little bit of gasoline on there, dissolve some of the glue.
In theory, maybe gasoline could actually dissolve glue.
That's basic chemistry.
They have similar properties, and so it's possible that you could actually use this nonpolar substance, gasoline, to dissolve something that's also relatively nonpolar, which is glue. So in theory, maybe, but there are so many things that would be better to use, and gasoline would be like the bottom of my list.
Are you sure it's gasoline, though?
Really
I should just try it again.
Woo!
Jesus!
Please don't huff gasoline at home. It's not a good high though, honestly, because the gas can get into your brain. It's one of those things that's very dense, like the molecule is very dense. It also could fill up your lungs, and then you can asphyxiate. Chemical brownies, Rick and Morty.
Okay, if we add a little more titanium nitrate and just a tad of chlorified tartrate, ovenless brownies!
Not even close on this one. Titanium nitrate is a colorless solid, and chlorified tartrate, I think you said?
Chlorified tartrate.
I am not familiar with that molecule. I'm pretty sure that does not exist. But let's just give them the benefit of the doubt and say they were using tartrate, which is essentially the salt of cream of tartar, tartaric acid.
Yeah, it's gotta be that way.
So we do eat cream of tartar. That's used in a lot of baking recipes. So that piece we could actually eat. But if you took titanium nitrate and mixed it with cream of tartar, you are definitely not making brownies.
It's incredible what a gifted mind can accomplish.
Sticky substances, Spider-Man, Homecoming.
Today we're going to be talking about Danish physicist Niels Bohr. But trust me, there's nothing boring about his discovery.
My big issue is on the right side. The left part, that ring, I'm okay with that. That's okay. But it's when we get to the right side of it and you see just like a line attached to this rogue carbon, and then you have another one attached to a carbon and another it's just garbage. So like that is just a disaster of a drawing. It's something I would expect from a high school student, and it's not good.
Boring about his discoveries regarding quantum theory.
This would not make a sticky substance at all. It would make a clear, colorless solution that kind of looks like salt water. In this experiment, we are going to make nylon, which is what I would make if I was Spider-Man. So I have 4 different things in front of me. To start with, I have a crystallization dish, and so this is a really round glass dish that is appropriate to make nylon in. I also have a spatula, and that's just gonna be to actually pull my nylon out. So I'm gonna start off by pouring this liquid just to have a little bit at the bottom. So I just want to cover my crystallization dish completely. Then I'm going to take my other reagent, my chloride, and I'm going to add that. And right away, we can already see the nylon forming. It's happening. It's absolutely working. Oh my God, I'm so excited. Oh. And I've made nylon. Look at this. And it just doesn't stop. It just keeps going, and I can keep pulling it in here, and I've made this like awesome polymer. Look at this. See, this is what Spider-Man should have done. Like, this is exactly what it looks like. Oh my God, it's just nonstop. Pew. Fictional elements, vibranium, Black Panther.
A meteorite made of vibranium, the strongest substance in the universe,
struck the continent of Africa.
The theory here is actually quite spot on. I mean, that's how elements are brought to Earth. There are explosions that happen in space. Maybe it's with a meteorite, maybe it's a supernova, who knows what it is. But eventually these pieces, these elements actually just like fling themselves onto Earth.
It's not just the metal. They sew it into their clothes. It powers their city, their tech.
Unfortunately, there is no atom or no element on the periodic table right now that resembles vibranium in any way whatsoever.
What are you talking about?
Cooking meth, Breaking Bad. In terms of safety, I'm pretty good with this. They have the gas mask on, then they have a piece over that protects their face, so that's going to protect their eyes and nose as well. And they also are completely covered in some kind of hazmat suit. I really like how they have their gloves all the way up, but then over the suit, so in theory, nothing's going to be dropping down into them. A lot of the equipment and the processes used here are very standard. So any standard chemistry lab, any industry place, any pharmaceutical place, those are probably going to have all of that equipment, all of that safety equipment, and in theory, you could potentially make meth there with that glassware and with the gas mask that you would need. That's a very common method. We use stills in our lab when I was in graduate school to purify our solvents. It's a really old school way of doing it.
2.35 pounds.
To make something that's like 2 or 3 pounds is a lot of material, and you would need to put a lot of reagents into that. Is it possible? Absolutely, for their setup. Gasoline fight, Zoolander. So bad. I would not douse myself with gasoline. That's typically frowned upon. It would smell terrible, but you're also extremely flammable. It's just not a good idea. I do not believe that small of a flame would be able to have that big of an explosion. I don't think the spark from the lighter would ignite it. The actual flame from the lighter definitely could light octane vapors on fire or gasoline vapors on fire, but it wouldn't have those big like explosion points, those boom, boom, boom that we see in that clip. Cigar explosion, National Lampoon's Christmas Vacation.
Sewer gas.
Don't drop that!
Even though the chemistry is not perfect here, I do like it. Sewer gas typically contains a mixture of hydrogen sulfide, some ammonia, some carbon dioxide, maybe some methane. The hydrogen sulfide is really what I'd be worried about there. That is toxic and it is extraordinarily flammable.
Yeah. Thanks for telling us.
And anytime you have gases that are trapped in like an area, that's when you can essentially make a bomb. And so if it's trapped in a small pipe or a small area, it's going to explode, it's going to push out. So you definitely will see an explosion, but not nearly like that. Cigarette explosion, Con Air.
Anara.
This is a big myth. Cigarettes rarely cause an explosion like this. You would need that cigarette to land perfectly, like have that light, that actual fire directly connect with any of that liquid that's flammable. But unless it lands perfectly, like this is just not gonna happen.
Looks like you missed your connection.
Chloroform Community.
Excuse me? Who are you guys? This is not your office.
So when you take chloroform and you put it on a rag and you try to smother someone, it actually takes quite a long time. I've never done it personally, but from what I've read, it sounds like it takes about 5 minutes. So you don't just immediately pass out.
What's happening?
Oh, we all got chloroformed.
With a small amount of it, you essentially get that euphoric feeling, that temporary euphoric feeling like you do with any other drug or alcohol. But then you pass out, like with alcohol.
Would you stop?
Testing for purity, blow.
What I'm doing here is measuring the purity. Pure Coke, it melts away at about 185, 190 degrees.
So by definition, when we use the word pure in the chemistry world, that means we have 100% of just those molecules. So pure cocaine would be a vial of pure cocaine. There's no meth in there, there's no cornstarch in there, it is just cocaine.
187. Where did you get this stuff?
So he's using a very interesting version of a melting point apparatus. We use this a lot anytime you're actually trying to characterize a molecule. So the first time a molecule is made and you're trying to publish that, you want to know the melting point. And so this is a really easy way for you to quickly test your material and see if it's good. Chemical burn? Fight Club.
This is a chemical burn.
I don't like it. He's intentionally throwing sodium hydroxide, which is lye, a base, a very strong base, onto your hand.
It will hurt more than you've ever been burned, and you will have a scar. What are you doing?
The movie's wrong here because it doesn't burn like that. That's not really what a chemical burn with a base feels like. That's more what it would feel like with an acid. When you put a base on your hand like that, your hand actually feels really slippery because it sucks the fats out. I know it's gross, of your hand, but it sucks the fats out of your hand and you start to feel like really slippery and you're kind of making soap, like literally on your hand.
This is the best soap.
Creating foam, Big Bang Theory.
We're going to combine these chemicals with ordinary dish soap, creating a little exothermic release of oxygen.
This science is good. Yeah, I'm all about this one. For elephant's toothpaste, which is the reaction he's making, what you do is you take concentrated hydrogen peroxide, so that's why he's wearing gloves, usually about 35% hydrogen peroxide. You add it to a mixture of dish soap, so some really bubbly dish soap, and I usually add food coloring to make it colorful. And then you add your catalyst, your potassium iodide, and that's what decomposes hydrogen peroxide to release oxygen gas. So yeah, Sheldon was right.
Sheldon. You remind me of a young Lex Luthor.
He uses the phrase exothermic release of oxygen.
Exothermic release of oxygen.
That means you're releasing oxygen and also releasing heat energy. So you probably can see at the very top or right on the outside of the reaction, you can actually see those heat waves, and it's just heat energy being pushed off as the decomposition of hydrogen peroxide occurs. So let's do exactly what Sheldon just did. We're gonna make elephant's toothpaste. So in order to do this, you need an Erlenmeyer flask, so something that's wide at the bottom and then narrow at the top. You're also going to need hydrogen peroxide, and you want concentrated hydrogen peroxide. You'll also need some dish soap. I highly recommend non-natural dish soap. And then I have my potassium iodide, which is a catalyst, and that's going to actually activate this reaction. Let's get started. So the first thing I'm going to do is add my hydrogen peroxide to my Erlenmeyer flask. So we'll just add this whole thing in here. Want a nice big reaction. Then what I'm going to do is add my dish soap in here. And so the dish soap is actually going to trap the oxygen gas that's released once I add my catalyst. Got to give it a little swoosh. Then we're going to add our food coloring. So this is the yellow. You could add any color you want, but I want it to match Sheldon's. I'm going to give it a little shake to prep my catalyst. This is the best part. And then on the count of 3, I'm just going to add this directly into my flask. 1, 2, and 3. Let's see what we get here. Oh! Yes! Look at this go! Isn't this amazing? So you have hydrogen peroxide, it decomposed, it released oxygen gas, which was trapped in the dish soap. We also see liquid water is actually condensing on the outside of the container. And then hopefully you can see all of this steam, these heat waves, because this is an exothermic release of oxygen gas, just like Sheldon said. Gene-altering chemicals, Spider-Man. Stay away from green gas. You never want to breathe in green gas. What I love about this is that he essentially is doing a really fun chemical reaction inside of his body. So the first thing he does is he drinks something, which is essentially a primer, some kind of molecule that will react with the gas. So he needs to have that in his body because we don't naturally have that. The green gas comes in and then like supposedly, magically, he has a chemical reaction between the two, and it's just garbage.
I'm something of a scientist myself.
Explaining a nuclear reactor. Chernobyl.
There are essentially 2 things that happen inside a nuclear reactor. The reactivity which generates power either goes up or it goes down.
His explanation of a nuclear reactor is beautiful. I love the way he describes it.
Fuel increases reactivity. Control rods and water reduce it.
Essentially what you do is you take a fuel source and you release energy from that source of fuel, and then you funnel that energy through the power plant. He does a great job of this because he really expresses how the nuclear fuel is dangerous, but it can be kept under control if you have all the other parameters locked into place.
It is beautiful.
Explaining a nuclear disaster, Chernobyl.
When the core is running at full power, it burns the xenon away before it can cause a problem. But Chernobyl Reactor 4 has been held at half power for for 10 hours.
I love how he talks about xenon and how cute is it how he says it.
Xenon.
Xenon's an inert gas, and so it really limits reactivity. It's not something that's very explosive. It doesn't really want to react with things. But at high enough temperatures, we can burn it off. And so when we have too much xenon present, but it's not at high enough temperatures, we essentially start poisoning the reactor.
At long last, we have arrived. 1:23:45, explosion.
What happened is they dunked these graphite rods directly into the water, and it essentially had enough energy to boil the water up, first of all, so the water is going to go from the liquid state to the gas phase, but it also had enough energy to split water into hydrogen and oxygen. And when hydrogen is around oxygen with enough pressure and with enough energy, it was so hot, it immediately becomes combustible. So we build up the pressure, we set hydrogen on fire, we blow the roof off, and then that's going to grab every single radioactive material in those nuclear rods, and they're just going to shoot them everywhere. And it was a huge problem. They believe the radiation was airborne for about 9 days. Just terrifying.
Safety first. Always.
Chemistry equipment, Mr. Bean, the whole bean. Don't do that. I hate that. He's not wearing goggles, he's not wearing gloves, he doesn't have a lab coat on. He put two liquids to his face that he doesn't know what they are and then mix them together. That's just like a big no. This setup is a disaster. It would never happen in real life. What drives me the most crazy is that all the tubes are basically wired backwards. You always shoot liquid, cold liquid into the bottom, pump up to the top, and then you filter it out the top. Every single one in this clip is set up backwards, and so the water's flowing in the wrong direction. Liquid nitrogen, Terminator 2, Judgment Day.
Hasta la vista, baby.
It's possible that you could cover something in liquid nitrogen and then shoot it and have an explosion like that. It's possible. Is it gonna happen exactly like that? Unlikely. Liquid nitrogen is one of my favorite things on planet Earth. So in the Terminator 2 clip, we saw that there was this liquidy thing that was frozen with liquid nitrogen and then it was shattered with a bullet. And so we're gonna try to replicate that. So the first thing I'm gonna do is put my safety goggles on. And then I'm going to put my cryogenic gloves on. Liquid nitrogen is cryogenic. It's very, very cold. I've got hot dogs. Hot dogs are gonna kind of replicate what happens if like human flesh went in there. Now this is disgusting. I'm just gonna put that out there. I have to stick my hand in there and get it. Oh, let me try to grab it. It is like rock hard. Oh my gosh. So that's like, we're gonna pretend human flesh that we froze with liquid nitrogen. 1, 2, 3. So let's use this experiment to conclude that if you dunked a human or a robot in liquid nitrogen and then tried to hit it with a bullet or a hammer, you absolutely would be able to destroy the villain. Case closed. Ingesting toxic chemicals, radium girls.
Watch me.
Don't do it. This actually used to happen 100%. They would dip the paintbrush in there and then put it into their mouth to get it into this nice like pinpoint tip, and then they would be able to very precisely paint these different dials on the top of clocks. And essentially what they're doing is using a paint that contains radium to give that nice like glow in the dark effect.
Everyone put down your brushes.
Radium is in the same group as calcium in the periodic table, so it means it's in the same column. Radium actually is going to get into these little gaps where calcium usually sits in your jaw, and so it kind of sinks into these holes and then it starts just like pulsing out radiation. So right away when you're licking the paint, it's just going to taste bad, but you're not going to notice the fact that you were absolutely killing yourself while doing this. But like a year or two later, when you've had enough radium deposit in these bones, then it starts shooting out these alpha, beta, and gamma rays, and that is what's actually causing cancer. And the dentists were the first people to figure it out because they were seeing all these girls come in with these huge issues in their jaw, and the only thing they had in common is that they all worked at the same spot. Invisible ink, national treasure. There are two common ways of using lemon juice for secret messages. One of them is if you have baking soda and you kind of paint the baking soda onto your surface, your canvas, whatever, and then you can actually use lemon juice and kind of coat it over there, and then it will bubble and kind of elevate, the secret message will. And the second way would be to actually use lemon juice to write the message, to actually code the message, and then you can expose it to heat and the message will appear. But neither of those things happened here, so this is pretty much just bad science.
No.
Sorry. Toxic chemicals, Casino Royale.
Oh, thank you.
100% you could poison someone this way. Sodium cyanide is very, very water soluble, so it looks like they dissolved the salt in water and then dumped it into the martini glass. So depending on how much cyanide was there, you absolutely could kill the person if there's enough. Yeah, this would work. It's very possible that he would start feeling nauseous, getting dizzy, the sweating, the really quick. And so all three of those factors together would probably clue someone like James Bond into knowing that he's been poisoned. There is one antidote that we know of, and it works extraordinarily well.
I'm all ears.
So the first thing you need to do is you need to inhale an amyl nitrate. That's followed by an IV that's filled of sodium nitrate, which is then followed by a second IV that has sodium thiosulfate.
That last hand nearly killed me.
Handling dangerous chemicals, The Rock.
Really elegant string of pearls configuration.
The VX nerve agent is absolutely real. It is a neurotoxin, which means it goes into your body and affects either your central or peripheral nervous system.
You know how this shit works?
This one specifically makes it so that your muscles can't relax. So your muscles can still contract, like your heart can still beat, but then it can't relax.
Oh my God.
The only reason you would use VX nerve gas is to hurt somebody or kill someone. There's no functional or practical reason to use it.
Twinge at the small of your back as the poison seizes your nervous system. Do not move that!
One of the biggest thing that drives me nuts about this is that we're seeing the VX in the gas phase, and it only exists in the gas phase at really, really high temperatures. And so these little green bubbles or those little balls are filled with green gas, which must be at high temps, yet somehow they're like just carrying it around without being around, so that like none of the science really matches for that. So it should really be in the liquid phase right now, which is an amber color.
All right, just back away.
Making water, The Martian.
I have hundreds of liters of unused hydrazine at the NDB. If I run the hydrazine over an iridium catalyst, it'll separate into N2 and H2.
Well, he's starting off with hydrazine, so N2H4, and so that's something that's used as essentially rocket fuel, and so he has a lot of that left over. And what he's going to do is then take an iridium catalyst, which again, found on his equipment, combine the two, and that breaks apart the hydrazine into nitrogen and hydrogen. It also makes ammonia, which he didn't mention, but I understand why he left that part out. So this chemistry is really clean here. Hydrazine is extremely flammable. It would be able to propel a rocket through space, which is extremely important. But in the context of this movie, there's a big piece that we've overlooked.
Because I'm stupid.
It's very, very toxic. And so if he's using hydrazine at all, he needs to be in some kind of hazmat suit, his spacesuit at the very least.
So yeah, I blew myself up.
I do not think he would have survived that explosion. Not at all. He would have had at least second-degree burns, but more likely third-degree burns, and those are painful.
Let's not talk about that ever again.
Conclusion.
So overall, movies typically portray chemistry in a explosive light. You see over and over again that a small spark causes a huge explosion, or a little huff of a molecule all of a sudden makes you pass out and die. What I love about that, though, is that people love including chemistry in their movies and in their TV shows, and so I will always be happy about that.